Hey, this is Contemporary Math, Section 7A, and we're starting our unit on probability. So suppose we toss two coins, and there are 4 possible outcomes for a toss of 2 coins. And you can either get a tail and then a tail and a head and a head, or a head and a tail. When you list out all the possible outcomes, this becomes the sample space, which is the set of all possible outcomes. So when we consider the possible outcomes, in this case, the order matters. In other words, getting a tail and then a head, or getting a head and the tail are 2 different outcomes. If we are interested in a tail and a head, just what's the probability of getting a tail and a head, then tail and head, or head first and then tail, those are events. So, which leads us to the definition for theoretical probability. Theoretical probability is the number of ways an event can occur divided by the total number of possible outcomes. So in our example of the 4 coins, what's the probability of getting heads? And we can see in our sample space that happens 1 time out of 4 total possibilities, which is 1/4 or 25%. The probability of getting a head and a tail, that happened twice, which is 50%. And the probability of getting 2 tails is the same as 2 heads, which is 1/4. And notice when you add up all those possible probabilities, you get 100%. And if you add up all the fractions that go with those probabilities, you end up with 1. Experimental probability, also called relative frequency in this textbook, is you would take the probability of A. This is, you just put capital P, and then the event in parentheses is the number of times that A occurs divided by the total number of trials. And the probability of not A would be 1, which is, 100%, minus the probability that A happens. So suppose a family has 3 children. One way to show all the outcomes of gender possibilities, gender at birth, is by using a tree diagram. I'm sure you guys have done these before. So this is what a tree diagram looks like. So you would list the choices for the first child. These would be the 4 choices of a second child after the first child was born. And then these would be the third child possibilities. So listing all the outcomes, you would just go boy, 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 girl, boy, girl, girl, boy, boy, girl, girl, and do that all the way down, and we can see that there are 8 possible outcomes. We could have figured out that there were 8 possible outcomes without the tree diagram, though, from the counting principle, also known as the fundamental theory of counting. So there are 2 possibilities on the first birth, 2 possibilities on the second birth, 2 possibilities on the third birth, and you just multiply those together. So in other words, 2 to the third, which is 8. So let's look at a probability distribution. So these are the possibilities. You could either have 0 boys. That happened 1 time when all the children were girls. 3 boys. That also only happened 1 out of the 8 times. The probability of 2 boys and a girl. is 3/8, and the probability of 1 boy and 2 girls is 3/8. And again, if I add all these up together, I'm going to get 100% or 8/8. And then if I were to graph that in a histogram, you can see that this is symmetric. So now, when we're talking about probability, then we also need to talk about odds. So the odds of event A happening is the probability of A divided by the probability of not A. The odds against an event A is the probability of not A divided by the probability that A would happen. So in gambling, the terms odds on generally means odds against, which is this one. So for an example, the probability of rolling a 4 with a single die is 1 out of 6. And the probability of not getting a 4 would be 5 out of 6. So the odds for rolling a 4, we would take the probability of rolling a 4 divided by the probability of not rolling a 4, which is 1/6 divided by 5/6, which if you remember how to multiply or divide fractions, it's 1/6 times the reciprocal of this. The 6's would cancel, and we would have 1/5 odds for rolling a 4. And this is usually stated odds are 1 to 5. The odds against rolling a 4 is the probability of not getting a 4 divided by the probability of getting a 4, which is 5/6 divided by 1/6, which is really 5/6 times 1/6. Again, the 6's would cancel, and the odds against rolling a 4 is 5 to 1. Here's another example with odds in gambling. So at a horse race, the odds on Blue Moon are given as 7 to 2. If you bet $10 and Blue Moon wins, how much will you gain? So 7 to 2 odds means that for every $2 that you bet on Blue Moon, you would gain $7 if you win. So a $10 bet is the same as 5 $2 bets, so you gain $35. Also, you get your $10 back when you go to collect on your winning ticket, so the total you would collect at the window would be $45. Oh yeah, and I forgot to talk about, along with theoretical probability and experimental probability, there's also what they call subjective probability. And this is an estimate based on experience or tuition. Like say, you would say, oh, the probability of my friend Paul getting married in the next year is about 80%. I mean, there's nothing you can really base that on other than your own intuition. So it's based on, it's subjective. It's subjective by your feelings. All right, your assignment for this section is the quick quiz 7A on page 437.